Okay, we're going to be doing inferences today. I know that you already know exactly what an inference is, don't you? Actually, it's a word that's probably new to you. To infer means to make a prediction or conclusion based on data or reasoning. Okay, it's not a guess. You're using data or reasoning to make a prediction. You observe some patterns and you conclude that the patterns will continue. Here's an example. Alright, in the first block here we see what? Yes, a very ugly dog. In the next block we see another ugly dog. Third block, still another ugly dog. And again, and again. So what can you predict, what can you infer will take place in the sixth box? Yeah, because the pattern has been an ugly dog in each one, you can conclude or infer that the sixth one will also be an ugly dog. Ah, it is an ugly dog. Alright, a restaurant manager selected a random sample of 20 customers and recorded the amount they spent on their meal. Based on this sample, which is the best estimate of the average, or mean is another word for average, amount that the customers spend on a meal at the restaurant. So the first thing we're going to do is find the mean or average, okay? So what we do is we add all these numbers up. So we add these up and we get 75. We add these up and we get 60. We add these up and we get 67. This column we get 69, and this column we get 59. Then we add all these numbers and we come up with 330. Do you remember what to do now? If you want to get the average or mean of something, you total up the numbers and then you divide by the total number of numbers. In this case, we've got 1, 2, 3, 4. 1, 2, 3, 4, 5 columns of 4, so that would be 20 numbers. So we divide by 20. And that gives us 16.5. So our average or mean is $16.50. Alright, use the average of the sample to draw an inference. Okay, if they've sampled 20 customers and the average that they spend is $16.50, then the inference that you might draw is that customers spend about $16.50 each when they come to the restaurant. Some more, some less, but the average is $16.50. Now, how can I use this information? Well, if I infer that the average customer will spend $16 per meal or $16.50, then I can predict what my sales might be tomorrow or next week or for the year. Well, how can I use that information? Well, that means that I can determine how much food I need to order to be able to prepare the meals. I can predict how many people I need to work during those days whenever I'm preparing the meals. I know how many servers I need. I need to know how much space I need in my restaurant. You can use that information to determine a lot of things. Alright, here's another example. There are 360 students at a middle school. Sonia, Jane, and Danny each survey a random sample of 25 students about whom they plan to vote for in the election for student council president. Results are shown in the table on the next page. So Sonia, Jane, and Danny all sampled 25 students. See, each one of these adds up to 25. 12 and 7 and 6 add up to 25. 7, 5, and 13 add up to 25, and so does this column right here. So they each surveyed 25 people. In Sonia's sample, Emma got 6 votes, Ty got 7 votes, and Carlos got 12 votes. Well, in Jane's sample, it was a little bit different, and in Danny's sample, it was a little bit different. We want to infer how many votes will Carlos get. All right, let's take Sonia's sample. In Sonia's sample, Carlos gets 12 votes out of 25. So we come over here and we put 12 over 25. And what we want to know is how many votes will Carlos get out of the whole population of 360? He got 12 out of 25 in the sample, so how many out of 360 will he get? So now we cross multiply 12 times 360, and we get 4,320. 4,320 equals 25x. We divide both, draw the line, divide both sides by 25, and we get x equals 172.8. 172.8. So we can infer that Carlos will get 173 votes out of the 360 based on Sonia's sample. So let's write up here 173. And let's erase the rest of this so that we can have room to work. All right, now what about Jane? In Jane's sample, Carlos got 13 votes. So we come over here and we put 13 over 25 because she got 13 out of 25 votes. And now how many out of the 360 will he get? We do go through the same process, 25 times x, and 13 times 360. That gives us 4680. Draw our line, divide by 25 on both sides, and that gives us x equals 187.2. So 187. So we can infer that Carlos will get 187 votes according to Jane's sample. So let's erase this. We'll put 187 here. All right, so now we've got Danny's sample has 15 votes for Carlos. So we'll come over here and we'll put 15 over 25 equals how many votes out of 360? We go 25 times x, and we go 360 times 15, and that gives us 5,400. We divide both sides by 25, put our line, divide by 25, and that gives us x equals 216. So based on Danny's sample, we can infer that Carlos will get 216 votes. Let's write that over here. So how many votes will Carlos get? According to Sonia, 173, according to Jane, 187, and according to Danny, 216. It says, and the next thing we need to do is describe the variation in the predictions. Now that sounds complicated, but all it means is describe the difference between the high estimate and the low estimate. Well, the high estimate is 216, the low estimate is 73, so the variation is 43. Okay? So it's just the difference between the high estimate and the low estimate. Draw an inference about the number of votes that Carlos will get. Well, what we can do with that is we get the mean. We take all three of them and add them up to each other. 3, 10, 16, 7, 15, 16, 17, 3, 4, 5. 576. We divide by 3 and we get 192. So we can infer that Carlos, and it's right next to the one in the middle, so we can infer that Carlos will get around 190 or 192 votes. Okay? So that's how you use data to make a prediction or an inference. A government inspector takes 5 random samples of the same size from a shipment of eggs. Here's our 5 samples. She determines the mean weight of a dozen eggs in each sample, so she weighs each one of these. What can the inspector conclude if the mean weights, the average weights of the samples are very close to each other? Well, if all these are, like if this was a pound and 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 this is a pound, then you can conclude or infer that the whole shipment probably every dozen eggs has about 1 pound of weight. Okay? Or if all these 5 are close in weight, then you could say all the cartons in here will be close in weight. If you find out that there's a big variance on these 5, then you can infer that there's a big variance among all the ones that are in here. How is an inference different from a guess? I mentioned this earlier. An inference is based on data, okay, that you've collected, and you make an informed prediction. Okay, a guess is just based on nothing. It's just how you feel, or maybe something like that. From a population of 500 Labrador puppies, I took a sample of 100. 55 of that sample were chocolate. So 55 of my 100 in the sample were chocolate. So out of the 500, how many would you predict or infer would be chocolate? We do this same thing. We go 100 times x equals 500 times 55. And that gives us 27,500. Divide by 100 on both sides. Put our line. X equals 275. So we could infer that about 275 of the 500 would be chocolate labs. Oh, remember this blast from the past? Find the median of the following numbers. Do you remember how to find a median? Well, what you do is you take the numbers. First thing you do is always put the numbers in order. So 3, 5, 9, 12, 16. And then you mark off one on each end, mark off another one on this end, mark off another one on this end, and 9 is the middle number, so that makes it the median. All right, so 9 was the median in that case. Now, let me show you something else. What if you had had another number here? What if you'd had number 4 there? Okay, so let's put them in order again. 3, 4, 5, 9, 12, and 16. We mark off one on this end, and this end, and this end, and this end. Oh, if we mark off each one of those, there'll be nothing left. So when you get down to 2 like that, you take those two numbers, add them together, divide by 2, and the median is 7. Even though there's no 7 in that group, the median number would be 7. The middle number would be 7. Okay? All right, now what is the average length of the words in this sample? Well, we've got one word with 5 words with 1 letter, 4 words with 2 letters, 5 words with 3 letters, and so on, okay? So if we want to find the average length of the words, we've got to go 5 times 1 is 5, 4 times 2 is 8, 5 times 3 is 15, 6 times 4 is 24, 6 times 5 is 30, 6 times 3 is 18, and 7 times 2 is 14. That gives us the total number of letters, okay? So we go add them up, we get 32, 62, 86, 101, 114. So we've got 114 letters. So we take that 114 letters and we divide it by the number of words. There are 5, 9, 14, 20, 26, 29, 31 words. So we go 31 into 114, that goes 3 times. 3 times 31 is 93. And let's see, that leaves us as 21. 31 goes into that 6 times, that's 186. I forgot to put the decimal right there. Sorry about that, because there's a decimal there. Okay, sorry. So each word is about 3.6 letters long. Okay? So you could make an inference that in that book or in that letter or whatever, that the average length of the word would be about 4 letters long or 3.6 letters long.